Hello student, in this lecture we will discuss about the electric current. In previous lectures we discussed about the electric potential and electric potential difference, as well as we discussed about the high potential body and the low potential body. Consider here is a metallic wire. Consider this is a metallic wire. This is a metallic wire. So as we know that this metallic wire is a neutral and it has equal number of electrons and it has equal number of protons, because this time there is no influence on these systems. Okay, so and in this metallic wire the positive charge that will be fixed at a certain point. Okay, but the negative charge will randomly move. Okay, the negative charge that will be randomly moved. The negative charge randomly move in any directions. The negative charge that randomly move in any directions. So what happens? This metallic wire have billions of free electrons that will be randomly moves or that have random velocity. The positive charge will fixed, because as we know that the positive charge concentrated at nucleus, that is called protons. So basically the free electrons that will be moved randomly in the metallic wire. When this metallic wire will connected between the high potential body and the low potential body, then what will happen? So when this metallic wire will connected between this high potential body and low potential body, there will be one phenomena that will occur, that is the negative charge body, that is electrons, that will move from lower potential body to higher potential body. So what happens when this metallic wire, which have random velocity of billions of free electrons, when that will be connected between these high potential and low potential body, they have gained some certain directions, and there is some electrons, there is a flow of electrons that will from lower potential body to higher potential body, and these electrons moves in a certain directions, and when these electrons move in a certain direction, that is called a drift velocity. That is called drift velocity. So drift means what? The forcefully or by due to influence of some external field, or due to influence of some external effect, the electrons will forcefully move in certain directions. So when this metallic wire, which has random velocity of billions of free electrons, placed between these two potentials body, that is high potential and low potential body, then there will be have electrons that gain the drift velocity, and the electrons will start to move from lower potential body to higher potential body. Okay, and this movement of charge produce an electric current in this metallic wire. Okay, so the current will flow from higher potential to lower potentials. Okay, the current will flow from higher potential to lower potentials. So CURRENT, current. Okay, that is also called electric current. Electric current. So what we understand that to flow of electric current, there is a need of potential difference between 2 points. When there is a potential difference between 2 points, and in that difference there is any metallic wire or there is any metallic systems or metallic body that will be connected between those potential difference, there will be the movement of free electrons from lower potential to higher potentials, and due to that movement of electrons, there will be a current, electricity that will be generated in that metallic wire, and the flow of current from high potential to lower potentials, and that is exactly called the electric current or current electricity. Okay, so how can we define the electric current? The electric current, we can define the net charge moved from certain area per unit time. Here one thing that we discussed, that when we find the amount of current, okay, or when we find that how much amount of current that will flow from that metallic wire in a certain time interval, then there is one necessary quantity that have time will added with the current value. So electric current is defined always with respect to time. So the electric current is defined through an area of a metallic wire or of a metallic body or of a metallic systems So electric current is net flow of charge per unit time. So how we define that electric current? It is defined as net charge flow per unit time. So in this way we can write that electric current is symbolized with I, okay, is equal to net flow of charge per unit time. So here we can write that I is equal to Q. The Q is the total amount of charge, that is Q is equal to NE. Initially in lecture 1 we study about these things, so Q by T. So here we can write that Q is equal to NE. So the number of electrons flow per the number of the net flow of charge, so NE, the net flow of charge per unit time, so NE by T. Understand? So what we understand, that to flow of the electric current or to generate the current electricity, there is a need of electric potential difference. So student, here we study about the electric current. So once again we see the formula of electric current, that is I is equal to Q by T. Now the SI unit of electric current is ampere. What is the SI unit of electric current? SI unit of electric current is ampere and it is denoted as A. So 1 ampere is equal to 1 coulomb of charge. The SI unit of charge is coulomb and SI unit of time is second. So what we see, that 1 ampere of current will flow in a metallic wire when 1 coulomb of charge will flow in 1 second. So 1 coulomb per second or 1 coulomb per second. So how can we define the 1 ampere of current? So 1 ampere of current, produced in any body when 1 coulomb of charge flow in 1 second. In this way we define the 1 ampere of current. So this is the electric current. Okay, now the electric potential or potential difference, it is also a scalar quantity, and electric current, it is also a scalar quantity. Okay, so electric current, that means electric potential and electric current and charge. These all three physical quantity are a scalar quantity. Why this is a scalar quantity? Because it has only magnitudes. It does not associate or it has no direction. Simply it has no directions. Okay, so this is all about the electric current. Now we will discuss about the direction of electric current. Okay. So now we'll discuss about the direction of electric current. So suppose there is a metallic wire. This is a metallic wire, and that will connect it through a wire. Or suppose what happens? Suppose this is a metallic wire, okay, and here one cell that will be connected with this metallic wire, and this cell this is considered as positive and this is negative terminal. That means this terminal at high potentials and this terminal is at low potentials. Okay, so this metallic wire will connected with high potential and low potentials. Here we suppose we apply a bulb, so this is a closed circuit and the bulb will glow. Why? Because this metallic wire will connect it between the high potential and low potentials. As we know that the electric current will always flow where the potential difference will be maintained. Okay, so now as we know that the electrons will move from lower potential to higher potential. So the electrons will move from lower potential to higher potential. The electrons will move from lower potential to higher potentials. Okay, but the direction of electric current will always from positive, yani ki positive to negative. That means higher potential to lower potential. That is I, and I. So here we see that the conventional direction of electric current is from positive terminal to negative terminal, that is higher potential to lower potential. So the direction of electric current will always from higher potential to lower potential, and the directions of electric charge will always from lower potential to higher potential. So this is all about the electric current and the direction of electric current. Okay, one thing that we have to clear from these all discussions that to flow the electric charge or to flow the electric current or to produce the current electricity, there must be a electric potential difference. There must be necessary to maintain the electric potential difference between two terminals. Due to that the charge will move between those two terminals. Okay, so this is all about the electric current. One more thing, that electric current is algebraically added. So suppose that this is here this is a part of circuit. Okay, so suppose this is a wire that will be connected. Okay, and now so here it is a switch, and consider here it is a switch. Okay, so this is S1 and this is S2, switch 1 and switch 2, and here we apply a potential difference, or here we apply a cell. Okay, the battery source between the apply this source or potential source in this metallic wire. So what happens if the switch S1, which has some resistance, suppose this is R1 and this is R2. Okay, so in this diagram what we see that there is a potential difference, or there is a voltage source that will be connected with a metallic wire, and here this metallic wire will be connected with the switch 1 and switch 2 in this fashion, and this metallic wire has resistance R1 and this metallic wire has resistance R2. Now the current will flow from this terminals to this terminal. So the final movement is here I. But what happens? There is some amount of current that will flow through the S1 or R1, and there will be some amount of current that will flow through the S2 or R2. Okay, if this will be connected. So suppose this is I1 and this is I2. So what happens? This I will be divided into I1 and I2, and when this I1 comes to this terminal, this point, and this I2 comes to this point, then here the net amount of current is again I, that is I1 plus I2. So it is always always remember that that the net amount of current in a circuit is always conserved, okay, and always constant. So the net amount of electric current is equal to the sum of electric current in different branches of that circuit. So here is I is equal to I1 plus I2. Okay, so these are the concepts of the electric current. So in next class we will discuss about the electric circuit, in which we will discuss about the open circuit and closed circuit, as well as we will discuss about the symbols of some electrical components. Okay, this is all about these lectures. Thank you very much.